Hello, this is Dr. Nimrod. Welcome to this session. We can talk about right now Heisenberg Uncertainty Principle. So right now we can solve the myths around the uncertainty principle. The main word here is uncertainty, which talks about two important parameters. One is certain and another one is uncertain. Before that, you are well aware that the Heisenberg Uncertainty Principle is a concept of modern physics, especially it deals with the matter, especially matter in the sense microscopic matter. So it is a concept in quantum mechanics. So before going into dwelling deep into what the concept really is, what the concept really is, we have to see what is certain and what is uncertain. So as I told you, Heisenberg Uncertainty Principle, any forms of physics, any matters of physics deals with matter. Any content of physics deals with matter. So it tells you how matter is certain and how matter can be uncertain. So what kind of matter? Either it may be a group of atoms, a golf ball, this pen, whatever it may be. A matter, which form of matter or what state of matter is certain and what state of matter is uncertain. So when Heisenberg tells you about the uncertainty principle, it was already established that the investigation of matter was in a fashion which is to be certain. So the main concept of Newtonian mechanics or classical mechanics study the matter, whatever the state it may be. The concept is classical or Newtonian mechanics study matter in its certainty. It study the laws of motion of matter and the laws of motion or the properties of the matter under investigation will be certain. It tells you that, okay, you have this pen, and if you want to throw this pen, the speed in which you throw the pen and the time it reaches there and the force that you give to throw the pen, all are certain. You can study the speed of the pen and you can study the destination point of the pen, provided given the force that you are providing to throw this pen. So that is certainty. So when you talk about uncertainty, it clearly antagonizes the point of certainty. So it clearly antagonizes the point of certainty in the sense, what it tells that the matter which was under investigation, whatever you wanted to investigate on a matter is not certain. So it gives you a cleavage in the branch of physics. So one point of physics, one branch of physics where you try to study how the matter behaves, how the matter moves, tells you that matter and the properties of the matter can all be certain. But another branch of physics tells you that no point. The point is that whatever the matter you are investigating, whatever the thing that you are doing, whatever the properties you want to study on those matter is uncertain. Which means that it was telling that, okay, you cannot study the matter in a whole. Yeah, fine. So this is an antagonism. Which means it is strictly contradicting the point of certainty in the matter. So it tells that when you give a force to throw this pen, you cannot study where this pen is going to reach, and you cannot study the velocity or the properties of this pen in motion. So that is the thing. So this seems to be a myth. So the myth is associated with the notion of matter. So right now we have to study what matter is. So in what kind of matter Heisenberg tells that there is no point of certainty. All that surrounds the matter is uncertainty. So we can take matter. As you know, or many students of physics can understand what matter is and how matter can be constituted. People might have in the higher secondary, they might have known there are states of matter, 3 states of matter, solid, liquid, gas, and 4th state is plasma, 5th state is Bose-Einstein condensate. That is all different. Matter here is nothing but an atom or a group of atoms, atom, group of atoms. Either it may be a bridge, it may be a pen, it may be a golf ball, whatever it may be. Now, how this point of certainty and uncertainty is connected to this matter? That is the question. When you are trying to understand the matter as a whole, for example, take it in mechanics. If you are trying to understand the revolution of Earth around the sun in the orbit, in the planetary fashion, or whatever the galactic celestial bodies that you want to study, huge in size, then the point of certainty is valid, because you can see, people can tell when the solar eclipse can come, when, for example, asteroid showers can happen. So these predict when they can predict when the lunar eclipse comes, when the solar eclipse comes, what is partial solar eclipse, what is the exact date and time, what is the exact location where you can see the eclipse. So it tells you that we can study a huge body in the fashion of certainty. So the laws of certainty or the Heisenberg Uncertainty Principle doesn't hold for body of huge mass. So what matter does this Heisenberg uncertainty is connecting to? So which is nothing but microscopic matter. So as I told you earlier, when I started this lecture, this is an important concept in quantum mechanics. We have told you during the course of lecture that there is Newtonian mechanics and classical mechanics. And right now I have told you what is quantum mechanics is. The Heisenberg Uncertainty Principle is a principle associated with constituent matter, microscopic matter, which can be fully studied in quantum mechanics or wave mechanics. So we cannot dwell deep into the wave mechanics. It is more philosophical question, because I have to tell you what wave is and what particle is, and we have to tell what dual nature of matter is. It is bit more. It will go a bit more complicated. So let us go directly into Heisenberg Uncertainty Principle. So right now you know that the uncertainty, the concept of uncertainty, which violates the concept of certainty, is not for the matter of huge size or huge mass, but for microscopic matter, which means an atomic scale matter, which can be a single atom, electron, proton, or whatever the elementary particles it may be, very small in size. So, what Heisenberg Uncertainty Principle tells you right now? So I told you earlier, imagine this pen as a microscopic matter or a single atom, and I am some omnipotent power that I can handle this atomic body, an electron or an atom, single atom. Either it may be a silicon atom, whatever the atom it may be. So I can handle it. So I'm giving a force to this atom. The force to this atom, and I want to study where the atom is. So the thing is that I am setting, for example, this is an atom. I am giving a force. For example, the concept of giving a force to an atom is a very big concept, and it was a chimera. We cannot go into that, because we cannot give a force to an atom simply like that, by like throwing this pen away from me. So, for example, I am giving a force or whatever fuel to the atom, or just further this force. Okay, I'm sorry, I cannot find just anyway. Yeah. What a piece of cloth. Okay, further the force, because we cannot develop more chimera. The aim of the physics is to simplify the problem, not to make it more complex. So see, so there is an atom. My intention is to see where this atom in space. So I want to find where the specific atom is located, or where this atom is going on. Heisenberg Uncertainty Principle says that in contradictory to Newtonian or classical mechanics, which talks about certainty, it tells that you cannot measure the properties of this atom in motion, which means that you cannot measure the properties of this atom in motion. That is very important. In motion, which means that this concept of atom being in motion is directly related to quantum mechanics, because the concept of matter being in motion is related to Newtonian or classical mechanics. Here, for a matter to be in motion, force is necessary. But for atom to be in motion, force is at another chimera. So the thing is that, so when there is an atom and it was in motion, you cannot measure its position or its momentum. The important point, it tells you that it is not telling you cannot measure. It tells you that you cannot measure it simultaneously. And the momentum of a particle in space at a particular point in a given time, which means simultaneous at a point. So if you want to, if you imagine this is an atom, if I'm throwing this or giving some kind, if it is in constant fashion of motion, I cannot measure its position and I cannot measure its momentum at a given point in a given time instantaneously or simultaneously. So it tells you, it is not putting you a barricade in the process of measurements, in the process of knowledge. It tells you that you cannot measure it simultaneously. But if you intend to measure the position and the momentum of the body or the atomic body simultaneously, you have to keep in mind that there is always an error in your measurement, which is completely absent in the laws, the certainty, which means completely absent in Newtonian and classical mechanics. But if you want to study, for example, the atom, the particular point, the position and the velocity, or the momentum P is equal to mv, which means velocity simultaneously, then you have to take into account an error in the measurements, and that error, it may be, is called Planck's constant. So this is the physical significance. I have told you it in a very crispy way because it takes a lot more than 40 minutes to deal all the philosophical significance of uncertainty, certainty, and how it goes on, and what is quantum mechanics, what is wave property, and it is all a different question. I wanted to be very crisp. So right now we can go into the mathematical point of uncertainty. Maths in physics is very important, and it gives you, and it tells you, or it gives you, it can reduce volumes of lectures, or it is like a poem. Maths in physics is like a poem. It is told by Albert Einstein. So the thing is that, I will tell you, as I told you earlier, we cannot measure the position and the momentum of an atomic body simultaneously. So the thing is that the change in the position and the change in the momentum is greater than or equal to h cross, which is Planck constant. It can be h1 to pi. Right now, I have already told you in the course of this lecture, when I was talking about the uncertainty and the position and the momentum of an atomic body, I was telling just by the position and the momentum of an atomic body cannot be measured simultaneously. But in the mathematical form, I have put a del x. X is nothing but position, and P is nothing but momentum. Okay? So the thing is that in mathematical form, I have introduced a symbol del, and I have told you x is position. I'm sorry, I'm just going. So the messy thing had gone now. So okay, let me write the mathematical form. del x and del t. So you know x is position and t is momentum. So what is del? As I told you earlier, a position and the momentum of the body cannot be measured simultaneously, but the mathematical form tells you a different thing. Del is the change, infinitesimal change, which means a small change. Del x is nothing but the change in position and the change in momentum. Change in momentum. So the thing is that I had told you earlier, when you are, if you have listened in the course of the lecture very clearly, I have made use of a word that if you intend to measure, because the law states that it cannot measure, but the same law states that if you intend to measure, which means that if you have an intention, why you cannot measure? I can measure. If you have an intention to measure the position and the momentum of an atomic body at a given point of time, then the change in the momentum, the change in the position and the change in the momentum is nothing but equals to the Planck's constant. So the error here is a Planck. You have to accommodate the error in your value. So if I am throwing this pen, if you have an atomic body and I want to measure this position and the vibration of the body or the momentum of this body, so I have to see, okay, the position is here at the time, the momentum should be this. So there might be a value x, there might be a value a, and this value a is associated with an error h cross. So that is the concept of uncertainty, which means that it again tells you that there is nothing uncertain and there is no barricade of, okay. So the thing is that it tells you that there is nothing uncertain. So which means that it is also a fashion. The thing is that it is a fashion that gives, it is not a barricade of knowledge, but it is a light or an illumination to put you, or a caution to tell you that, okay, if you want to measure an atomic body at the same point of time, the position and the momentum of an atomic body, the thing is that you have to take into account the error, which is nothing but the h cross, and whatever the value a or b you get, it was associated with the error, and that is the point. So Heisenberg Uncertainty Principle is not just a barricade of knowledge, and it doesn't tell you that, oh, you cannot learn anything or you cannot learn any atomic body. It is far beyond the human knowledge, but rather it tells you that you can measure the atomic, even a very small body in the universe, given accounting to the error, which is always associated with the simultaneous measurements. That was a point related to wave mechanics, and it is a different chapter. That's it all for now. Thank you. This is Dr. Nimrod for you. Bye.